Uh, Today's session is on UAV remote sensing. Now, this word unmanned aerial vehicle or drone has surged in the last 2 decades. Around last 2 decades, it has become very popular instrument for a wide range of applications. Initially, it started with as a hobby thing to do some, flying hobby flying clubs had these drones, and then slowly it found its applications into wide range of themes, and it has also in recent times led to a remarkable number of scientific contributions, specifically in the field of remote sensing, image processing. The main advantage being the flexibility and the low cost, the moderate cost which drones have. Now, as you all have been listening in the last few weeks on remote sensing, the journey of remote sensing started initially with balloons, aircrafts, spacecrafts. So we have wide range of platforms from where we can do or collect information about the Earth's surface and make inferences about it. And each of these platforms have their own advantages. I would say they have their own benefits, pros and cons, the drawbacks. For example, let's talk about the most popular one, which is now used for collecting data of the Earth's surface, is the satellite platform. The main advantage or benefit of a satellite platform is it provides a synoptic coverage of the entire Earth's surface with a large range of spectral capabilities. But the major drawback being is the spatial resolution. The highest which we have is 30 centimeters. If you want still higher, maybe in times to come, we may have higher spatial resolutions, but at the moment, the highest resolution we have is 30 centimeters. Then the temporal frequency, that is, we get the data not when we require. They have a time-bound or frequency. For example, they have a bi-weekly or once in a week or once in 15 days, 2 weeks. So it depends on the satellite configuration. So the temporal frequency or repetitivity of the satellite varies. But nowadays, with the constellation of satellites, with having large like the doves, they have tried to improvise on the frequent coverages of an area or a daily visit. But then those are limited, and the cost is also quite enough, large enough if you want to have this. So one doesn't get the data as and when he wants the data, and the highest resolution, as I said, is 30 centimeter, and the cost of the higher resolution data is very, very high. In contrast to this, I mean, in comparison to this, if we compare it with an aircraft, then they provide a very high spatial resolution, maybe around 5 to 7 centimeters, but they are very expensive. Aircrafts to fly, to plan a mission, it itself is a huge task, and the cost is quite higher. And the operations of these aircrafts are also susceptible to weather and cloud conditions. So, though they give you a very, very high resolution data sets, but then planning an aircraft, permission of an aircraft, because they are all manned missions, the cost factor is higher. And another aspect is they have capabilities. The sensors which are available, they operate in a certain spectral ranges. Third one is the ground-based sensors. So the ground-based sensors, they give you the highest resolution, if I say so, but then they are placed on the ground. They do not have a large coverage areas, and they give you very small locational areas that you cannot have a large coverage. So they're primarily used for validation and calibration of air or space-based observations. Now, drones, they are somewhere in between, if I say so, the satellite or the aircraft and the ground observations. So they are the low-cost version of airborne sensors or aircrafts, which provide a lower coverage area as compared to aircraft or spacecraft, and are more suitable for mapping. I mean, they're suitable for giving you data for a smaller areas, sampling smaller areas. So they are also filling a gap between the aircraft and the ground. So they also provide you high spatial resolution data sets, and also an advantage, they give you high temporal frequency. That means as and when you want the data, you can plan a mission immediately. It doesn't require a large amount of planning. Instantly, you can, immediately you can plan, and within an hour or so, you can fly in that area and collect the data. And these drones also play, they play a key and a complementary role in the entire process of remote sensing, especially for certain applications. One of the examples when I can give you is for disaster management, where the information which you want is time is crucial. The information, time is crucial. You want it immediately to take remedial measures, mitigation actions. So the information has to be obtained and disseminated as quickly as possible wherever such applications are there. Then drones offer a high versatility and flexibility as compared to the airborne or spaceborne sensors. And they can be, as I said, you can immediately plan, operate, and rapidly plan without any planned scheduling. So they have a flexibility of operations to fly everywhere, every time. And you can install, nowadays with the advancement in the electronics and instrumentation technologies, you have lightweight sensors, so you can install any kind of sensors. And they have a much reduced cost to the other approaches. And another advantage of the drone platforms is they are unaffected. You can fly below the cloud cover, so they can give you data which is not affected by cloud cover, as they can fly as low as possible and give you very, very high spatial resolution data sets up to 1 centimeters. Now, drones can be classified based on their performance characteristics. They can include weight, wingspan, wing loading, range, maximum altitude which they can reach, the speed which they can fly, the endurance means that maximum time factor which they can fly with, right? And some of the major factors which are there based on which drones are classified are basically size, flight time, camera capability, takeoff, and altitude level. In general, there are 3 major divisions of classification criteria are weight and size, range, and aerodynamics. So as per the Indian DGCA policy, there are 5 categories of drone based on the weight and size. They are nano, micro, mini, small, and large drones. So nano drones are the ones which are less than 250 grams. Micro lies between 250 to 2 kg. Mini is 2 kg to 25 kg, and small is between 25 to 150 kilograms. And the larger drones are 150 kilogram drones. So the permissions to fly, all these are governed by the categories of the weight sizes. So if you have a nano drone which does not have any sensor, you can use it for a flying hobby club kind of activity, then permission is not required. The moment a sensor is installed, you have to take permission for flying. And similarly, micro, mini, all of them require a certain amount of permission. Small and large, they are the ones which has heavyweight sensors which require specific permissions to be taken and clearance from the civil aviation to fly. Similarly, based on the range, the maximum horizontal range which they can fly, you have close range, short range, medium range, and in medium range with more than 200 kilometers. So one is with 10 to 30 kilometers, short is between 30 to 70. That is the maximum horizontal distance which they fly, and this is also dependent on the endurance, which is the time of the flight. So based on the battery or the energy power which they have. So in general, lightweight drones, they have a smaller battery power, their range is shorter. So endurance time is maximum 20 minutes, 30 minutes. And the heavier drones which have a more power or powered batteries or fuel, they have a longer range and a longer endurance. They can fly more than an hour, around an hour or so, they can fly and collect the data sets. Then the third category of drones classification is based on the aerodynamics principle. where we have a fixed wing and a multi-rotor drone. Fixed wing drones are like an aircraft which has a fixed wing, and the multi-rotors, you can say, are like resemble like an helicopter, which you have many rotors on which they can. The aerodynamics principle is that based on which they take off and fly on in the air. So different the weight and size basically and the range is all based on the weight size is the major criteria which defines the permission level and the payloads which they can carry. Aerodynamics is basically based on the aerodynamics has an applications. So different modes of whether it's fixed wing, multi-rotor, or nowadays we have another one which is a hybrid version of it, which combines the advantage of both fixed wing and multi-rotors. So we have a third category, which is a hybrid, which looks like a fixed wing, but works like a multi-rotor kind of drones. So out of the fixed wing and multi-rotor, based on the applications, one can use the out of these two categories of drone. So fixed wing, like an aircraft, they have a more battery power and they have a larger endurance, so they can fly for a longer distance, but they do not have the flexibility to hover at an area. They cannot stand at a point, nor so they have this drawback. And whereas the multi-rotor ones, they can remain stationary like a helicopter. They have these rotors, they can remain stationary, and they can also move in a rugged terrain. Because another disadvantage of fixed wing aircraft, the drones, is they need a place to take off and land. So you need a landing and a takeoff space. So in a highly hilly terrain where you do not get around a few meters of an area where the aircraft, the drones can be placed, they can get a space for a takeoff and landing. So that becomes a challenge. In those scenarios, the multi-rotor ones, which do not require, they can take off from one point and land at one point. So those can be utilized in a rugged terrain. So these are different types of multi-rotor drones for a large-scale remote sensing applications. You have quadcopters, which has 4 rotors, right? Hexacopters has 6. So the more rotors they have, more power they have, and more weight they can carry and fly in the and collect the data, right? So as I said, the advantages and disadvantages of each of them. Multi-rotor, that's accessibility, ease of use. It has a vertical takeoff and landing. They can hover at a point and can operate in a very small confined areas. But they have very short flight lines, that the endurance is less, and they have a very small, they also have a small payload capacity. Now, fixed wing, they have a long endurance. They can fly for a longer distances, collect a larger area, and the fast flight speed is there. They do not have a vertical takeoff and landing. They cannot hover at a point, and they require a little more training to fly these fixed wing aircraft. So we have a third category, which we said is a fixed wing hybrid type, which has a vertical takeoff and has a longer endurance like an fixed wing category, but they cannot hover at a point. Still, a lot of work is doing. So they try to operate like a multi-rotor, and they multi-rotor by vertical takeoff and landing, and also has an advantage of a longer endurance like a fixed wing. But still, there are certain limitations with the fixed wing hybrid kind of the drone systems. Now, if you look at the drones here, the major components of a drone, which you will see here, it has these are the major components. It has a GPS and an IMU. The GPS and an IMU is basically used to navigate the drone. The drone needs to be navigated. They need to reach places. They need to move around. So GPS and IMU unit provides the coordinates to where the drone can move, right? Then it has a flight control system. It has a battery power, which controls how long it can fly, the energy which it supplies. Then this is a gimbal, and you have a sensor on which the sensor is placed on the gimbal provides the stability to the sensor so that the motion of the drones will not affect the quality of the picture. And you also have the ground control station. Ground control system, it's like a joystick by which you can monitor. It's like when you play any kind of an toy and you want to control it by a remote. So it's basically a remote for the drones which you can monitor. You can do the entire flight planning with this ground control station, and you can monitor the path of the manually. If you want to control, you can monitor it with the help of the ground control systems. So your IMU is basically providing the it basically detects the current rate of acceleration. It changes in the roll, pitch, yaw. So it tries to monitor the roll, pitch, yaw. So these are the major components which is there onto the drones. Then in addition to that, drones also have certain other sensors on board it. Like it has a sensor which is obstacle detection and collision avoidance sensor, which basically they are placed there to detect if any bird or any kind of any kind of object is coming closer to the drone, so they move away from the drone. Even while landing, if it is coming closer to a building wall, it shouldn't crash into the wall. It moves away from the wall. So it's an obstacle detection sensor. So it tries to find within a range if any object it tries to sense to it, it moves away from there. Then, as I said, gyroscope, stabilization, and IMU and flight controllers, they give drone its smooth flight capabilities. The gyroscopes provide the essential navigational information to the flight controller. The IMU detects the changes in the rotational attributes like the roll, pitch, yaw. And the IMU is an essential component of the drone flight controller. Basically, the flight controller is the brain of the drone. Then we have all drones, as we said, has the ground control station, or it can be what I showed you, a instrument like this, or it can be operated from a smartphone by installing an app in it. And it provides it from there. You control the telemetry parameters. You try to navigate, tell what height the drone will be, what will be the speed, what is the area which it will fly, and how much remaining battery power is there. So based on that, you can call back the drone to the ground station, to the ground. Then gimbals and fin control. Gimbals are basically nothing. They are stands which allow the camera to be placed on it with sufficient stability, and it reduces the vibration within the camera so that the picture qualities are better collected. Now, with drones nowadays are equipped with different kinds of payloads or sensors. So it can be a wide range of payloads, which can be like a photo, a simple camera or a video camera, a thermal imager, a magnetometer, a gas analyzer, a laser scanner, a hyperspectral scanner. So any kind of payload you can choose depending on the task which you want or what kind of data you want to collect. So, but you should be, for example, if I want to do agricultural application, then one would select a multispectral camera with a near infrared capabilities, imaging capabilities, and also along with that thermal imaging capabilities. So depending on your applications, you try to choose what is the kind of camera you would purchase or you would buy and install it on the drones and collect the information. So wide range of multispectral sensors with number of bands are available. Similarly, you have hyperspectral cameras both in the near infrared range up to near infrared and also in the shortwave infrared. But with hyperspectral, the weight of the drone slightly becomes higher because of the weight of the sensor in the shortwave region. But if you buy it with the near infrared region, the weight is still on the lower side. But many times, depending on the drones which you have purchased, it's a single sensor operated vehicle. Otherwise, you will have to choose a UAV with an interchangeable payload. You have to fix certain gimbals at the bottom in which you can attach a number of sensors at a time. Otherwise, maximum 1 to 2 payloads can be attached at a time. But then you have to design it so that a number of sensors can be placed. Now, another aspects which I would say for the drone is the operating conditions. The drones, another important feature when you purchase a drone is a kind of operating, is a weather conditions under which they can fly. The wind speed, precipitation, air temperature sometimes limit the choice of the drone. So you have to be careful enough. So one should choose equipments which is intended to be used for a wide range of temperatures and can withstand a significant amount of wind speeds. Specifically, when you are wanting to operate the drones in a harsh environments like mountains or at a very low or high temperatures, it is advisable to buy a drone with a model of drone which can adapt to these conditions. Then another thing is the reliability and portability of the drone. So it's very important that a UAV is reliable and portable and does not require lengthy preparations to start. So you should, when you purchase a drone, then one should keep in mind these points. Material used should be light and strong enough to carry the payloads during the flight and also during the landing. And it should be portable enough. You can carry easily from any place to place. So the time needed for preparing a drone for flight should not be few minutes. It should be within a time limit, right? Then this is the complete architecture or hardware software required for drone remote sensing. You, as I said, you require a drone with a ground control station, then the payload which you want to fly, and then you need to have a flight planning software which is attached with the drone itself, which I said it is there in the ground control station, which is a software which allows you to plan the entire flight, what is the area you want to collect, what are the flying height, how much will be the spatial resolution, which will be the pattern of flight, how much area needs to be covered, can it be covered in a single flight time, because the endurance of each drone is in general is 20 to 30 minutes unless you go for a fixed wing and a larger weight drones which has a larger endurance of more than an hour. But here if it is 20 to 30 minutes, your area is large, how many flights you will be able to cover. So all this parameter needs to be planned in this flight planning software. Then you need a powerful workstation because the volume of the data is tremendous. So you need a good workstation to process these data sets, and simultaneously when you're flying and collecting the ground, to georeference your drone data, you need to have a GPS, DGPS systems from where you can collect the GCPs on ground and georeference your data. But nowadays drones are also coming up with onboard GPS, which is in the PPK and RTK mode, which in that case you don't need to collect the GCPs on the ground, but those drones are specific category drones which are equipped with onboard GPS for direct georeferencing your data sets. They are slightly expensive, and also the weight of these drones are slightly higher. You cannot add many sensors to it. If you're doing a normal multispectral camera photography or an RGB color photography, they can be utilized in those cases. But if you want to add multiple sensors on drones, the weight category would become much higher. So all, as I said, the flight planning aspect parameters are added on the flight planning software. So this is the entire workflow of UAV drone systems. You can plan and upload the flight planning parameters. You can choose your drone, your sensor, everything, the battery, everything, the power, and accordingly you can upload which are the areas you want to fly, capture the data, then process the data to produce the required output. So the image acquisition plan, the flight planning is one of the major steps. If you do this properly, the data collected would be precise and it will be useful for your application. If this is not done properly, you may have challenges in processing the data sets. So the flight planning parameters include identification and specification of takeoff and landing sites, flying height, direction, speed, number of flights, overlaps, how much will be, if you're trying to do it for generating height information, extracting height information, then the two photographs should have a certain amount of overlaps. So these are there. So in this case, you need to designing the image acquisition plan. That is, what is your data? You're going to collect it from aerial, terrestrial, or it's a mixed combination. What kind of object? It's a building. If you want to fly and collect all floors of the building, or you want to collect it from the top, side view, oblique view. So what is your purpose of the data acquisition? Accordingly, you will plan. Then type of the terrain, the type of the camera. It's a panchromatic camera, multispectral camera, thermal camera. So all these are there in the image acquisition plan. Then strategy, whether you want to collect it as a regular square or a rectangular grid. Your area is a square or a rectangular grid, or it's a circular grid. In what rate or what manner you want to collect. Then the image rate that the images are taken. If more than one flights are needed to cover, that also you need to fly. Then this is, as I said, the entire mission planning software which comes. There are free mission planning softwares also. Some are commercial and some are also open source, which are there. So for example, I can give you the flying height. You need to determine how high you would like to your drone to fly or the UAVs to fly. It depends on the spatial resolution required. The relationship between the height of flight is related to the spatial resolution of the images you want and the focal length of the camera which you are using. So there is an inverse relationship between the spatial resolution and the flying height. The higher the flying height, the lower is the spatial resolution. So for example, flying height of 145 meters, I would say, will result in images with a spatial resolution of 5 centimeters. On the other hand, a flying height of 290 meters will produce 10 centimeter resolution images. So it depends on what you want. Accordingly, you define the flying height. Overlap is, if you want, as I said, if you want to have these images, you want to use these images to generate a height model or a digital surface model or a canopy model, then you should have a sufficient overlap between these two images, about 70 to 80% to generate the height information. So this is the mission planning. As I said, you define the area, you see the polygon inside, you define this is the area which is to be covered. Then based on the battery power of your drones, you can determine whether it can be covered in a single flight or a multiple flight. Then after, what will be the interval of data collection? Then you identify from which point it will take off and what point will be the landing site, right? Overlap, speed, again, will be determined on based on the number of data sets you want, right? And then you can also collect the GCPs simultaneously on the ground. So if you see, this is an example of the data collected using drone from different angles. So this is not only from the northern angle, you can see there are oblique. So it's trying to map the landscape, getting the height information of the landscape. So it's not only the northern view, but it's also from the oblique views, different terrain features are imaged. Now, these are some more examples of the images, this is from a simple RGB cameras. You can see even a mobile camera can give you this. This is an image on the left-hand side is from a multispectral camera, which has 5-band cameras, which has the red, green, blue, near infrared, and the red edge band. Red edge band has a sensitivity to vegetation, health. So this also has a red edge band. This is another, the images on the right are the ones captured with a thermal camera. So one can capture the data, the image, both during daytime and nighttime, and assess the temperature variations and the thermal inertia, which can be used for various applications. And also can be used to collect nighttime images. So these are few examples of drone data which is being collected in our campus using various sensors. Simple RGB, using multispectral sensor, and this is an FCC of the infrared, red and green band, and thermal sensor which is there. So this is how the path was flying. So this was the takeoff site and this was the landing site. So you can plan and collect the imagery. This is the near infrared imagery, the red data. We can calculate, you had lessons, how do we can calculate the NDVI? The NDVI for this image was generated. Right? So this is again the thermal view. So accordingly, here it gives this data needs to be calculated. It gave us a temperature, that what is the range of temperatures during daytime and during nighttime. So one can calculate. So after the images are obtained, we can process these images to get a wide variety of products. Like this, you can get an ortho image, you can generate a relief map, you can generate a complete 3D perspective, you can generate, you can create a fly-through of the entire terrain, digital elevation model, contours one can do, and extract thematic information as per your own requirement. Land use, land cover, road network, water bodies, urban extraction. So any kind of thematic layers one can extract. So this is the various applications of drones where it has been, it has a significant potential and it has been widely used also. One is in creating a large scale maps. This is one area where we created 1:2000 scale topographic map using the drone data sets. So one can create a large scale infrastructure map for the urban areas. For any areas, one can generate a large scale 1:1000, 2000 scale maps of the terrain features or urban features, which can be also, this data can be directly ingested into a GIS environment for any kind of analysis. Since it provides you very high resolution data sets, we can use it for land management, for agricultural applications. It has a very tremendous use. Now, even government is promoting drones in agriculture sectors very effective. I mean, it has found its use significantly in agriculture, and from government is giving a lot of incentives, and many startups have come up who are now promoting or using, trying to develop drones for use in agriculture sector, and specifically for precision agriculture, crop insurance, and for pesticide spray. So you might have heard also that they had been used in the locust case to spray and the pesticide sprays when there was a locust attack. And for terrain modeling also, you can generate a complete 3D information, depth informations, and also for infrastructure, monitoring of infrastructure development projects like railways, roads, buildings, and power lines. So they are there. Cultural heritage monitoring, if there is any damage. I'll show you some examples. Mining sectors, they have been used for monitoring the mined areas, how much is there to estimate the volume and extraction in mine excavation planning. Forest and wildlife monitoring, forest fires, disaster cases, again, they have a significant, a wide range of applications and have been effectively used for rescue operations as well as for damage assessment. Drones have been effectively deployed, and marine and coastal applications also, they have a segment. You have underwater drones. So these are not surface drones, they are air-based drones. These are underwater drones which can be utilized to map the sub-ocean features within the ocean. So these are few examples which I will try to show you. Is what we have done is some of is done by us, and some of the examples which I've cited here is this is an example of one of the areas where we collected the drones. This is one few around 7-8 years back, where we collected this data at around 500 meters and 750 meters of the topographic area, just to find out, to estimate that what is the accuracy or what level of information we can extract about the terrain from these UAV images as compared to the satellite-based observation, or what extra benefit these observations provide us in comparison to space-based observations. So we had done drone flying, collected in a very moderately hilly terrain, closer to in Dehradun, And if you could see, this is the bare earth model we could generate from the drone data sets, because the point density of the digital elevation model was so high that we could subtract the terrain features like buildings and trees from it and create a bare earth height. So in general, this bare earth height cannot be generated from a space-based stereo data sets because the resolutions are so high, but not up to that level to give you the bare earth information. Whereas in this case, the point density was so high, the resolution is so high that we could generate the bare earth information. Generally, otherwise, the best way to get a bare earth model is through using the LiDAR data sets. So what I'm trying to emphasize is the detail which I can map is the one which I can get it from a LiDAR data sets. So we could generate this bare earth information from this drone data, which was collected at a spatial resolution around 14 centimeters, and also a topographic map of 1:2000 scale, and a contour of 1 meter. Contour level could be mapped, and in this contour, if you can see, there are orchards which are there. I can show you. There are orchards there, and these are the orchards. The mango trees are there. You can see at 1 meter, each canopy, within each canopy, this mango orchard could be mapped. Similarly, we can extract the slope information. The slope also was very precisely extracted, and the range of slope values was higher as compared to when we compared it with the place-based Cartosat information. Now, look, this is a profile along a certain direction. Now, look at the level of detail which was extracted from a drone as compared from a Cartosat satellite. So Cartosat, most of the minute subtle variations was not captured, whereas here, even the minutest, smallest subtle variations were captured with the drone observation. Similarly, on another side, when we took a horizontal surface profile, then you could see small subtle dips, mounds, they could be visualized. And the accuracy of this was very in line with the ground-based GPS datasets. So wherever we collected, we tried to match it with the GPS, which is most accurate information. So the positional as well as height accuracy was comparable to the one collected on ground with the DGPS datasets. So this is how it is there. We collected with Cartosat, with GPS, and compared the Cartosat, GPS, and the drone datasets. So GPS and the drones were in sync with each other, where there were small variations with the Cartosat observations. So as I said, we could map the contours at 1 meter contour level. These are few more bare earth height extraction, which is there is a fault which is there, which gives you a data closer to the laser observations. Similarly, when we try to map the perimeter, we try to map the area, the perimeter of each object. This is a boundary. And similar was done with the terrestrial laser scanner on ground. We tried to compare the metric measurements using drone as compared to what is there on the ground. So we compared it with laser-based observations on the ground with the measured from the drone. So there also the accuracy was very precise in comparison to the what we get from space. So when we need very precise level of information, minute subtle variations of the topographic terrain, then drones are the ones which provides you this data set. So this is a slope profile along an agriculture field, which was compared with the terrestrial laser scan total station. And if you see, it is matching with reference to the drone data sets. This is a topographic map which we generated for 1:2000 scale. Similarly, using this, we can extract the features, built-up structures, vegetation. We can extract the individual trees, even know the health of the trees. If you have the relevant band, the red edge band, we can also get the health of the plant or the tree, and not only the height, the canopy structure, everything can be extracted. We can count the number of trees. So you can do for an orchard management. each buildings also, we can map the number of buildings. You can do an automatic using deep learning algorithms, automatic image processing methods. The roads can be extracted, the water bodies can be extracted with the highest accuracy. So these are some of the examples where densely populated areas, slum areas, because the resolution is such high that one can capture each smallest detail, map them, and make an inventory of them. So this is a mango orchard. We can count, map the crown of the size of the height of each tree and make an inventory. This is another analysis which was there where we can do how much is the sediment deposition happening in the riverbeds. So this is one example where we did a pre and the post monsoon analysis. Pre-monsoon, the data was acquired. Then post-monsoon, how much sediment from the was deposited on this riverbed, carried from the upper hills. That those kind of analysis one can do and then assess for the further measures to be taken in this case. So another example is where it is, as I said, it is in case of the we had a request where there's a landslide zone in Nainital. It's called as area is a Balyanala area, which is very sensitive. This landslide is very sensitive to rainfall. If anything happens, it may slide and then may affect the residents who are staying there. So in this analysis, we tried to collect the photograph. And if you look on the right-hand side, this is the condition when we did the acquisition. It was foggy. It was basically a monsoon season and it was cloudy. But then since these drones could fly at a very low level, one could collect the data and the clarity of the data, if you see, it gives you. And from this, we could generate complete 3D information and the topographic information. What is the slope? And accordingly, action, if there is a slide, what are the areas which will be, if there is a landslide, which will be the area which will be affected? One can calculate from this and give a forewarning to the residents there that you need to vacate these areas. So see the level of details here also, we could capture a 1 meter level of contour and the subtle variation in the slide areas. And if there is a slide rainfall, if it slides, what will be the area which will be impacted can be estimated, and the government can take remedial measures also to stop the slides from further creating havoc. This is another example where we did a simulation of if a landslide is triggered, this is the height, then the debris will flow at what, from this height, what will be the velocity and which will be the area impacted. If we can calculate that, for calculation of this, we need a very, very precise slope information, which we compared it with this entire study, we compared it with the space-based observation, because space-based observation, the data is collected from the top, and we are not able to capture the slope very precisely, whereas using the drone was flown along the line of the slope itself. So it was flying, we have flown it like this. So very precise slope information was gathered. And when we did a simulation exercise by what will be from this flow height, if the landslide is triggered, what will be the velocity and which are the areas which will be impacted, then this we can do. Once it is triggered, then immediately administration can take action and ask those people and they will know which are the areas that will be impacted, and those people may be evacuated and lives and monies can be saved. So this is one simulation exercise we did. This is another example where it can be used to assess the damage in the monuments, as that I said, for the cultural heritage monitoring. This is a violent earthquake hit the Myanmar on 24th August, which damaged its 14th century archaeological site, which is a temple there, Sulamani Pagoda, which is there, and it was damaged. Now, how much is the damage could not be assessed. Another drawback of satellite images, the acquisition time is around 10:30, and it depends. some of the areas remain shadowed because of the solar elevation. Now, when the satellite data was captured, this area where the damage had occurred was there on the shadowed region. So one could not process this and assess the damage. So this is a limitation, that it is restricted due to the view directions. The satellite was solar satellite combination directions, it is limited. Whereas drones, since you can fly anytime, anywhere, so you could cover the damaged portion also. And then damage assessment both during shadowed and non-shadowed regions can be done. And volume, how much of the debris was created, which are the area impacted, was easily estimated with a very, very high accuracy. Similarly, quantification of the deposition of debris also was attempted in the glacier region, where a massive debris flow occurred near the snout of the Gangotri Glacier in 2017, and it resulted in a major geomorphic changes in a very high elevation areas. So this exercise was also done by combining pre-event. We did not have a drone flight. It was done from the satellite-based observation, and post-event was from the drone. And combining this, the quantification of how much was the debris deposited and what is the changes it caused in the landform was estimated with precision. So this is the advantage. Another is a sand query volumetric estimation. This is one of the papers which is published, and which were in the district in Tamil Nadu, where they have tried to generate that excavation done in the sand for sand query to estimate whether it has been done within the limited permitted value, or it is done more. So whether there is an encroachment done by the villagers in the river areas. So all this, for monitoring purposes, one can use this technology quite effectively. As I said, in agriculture sector, drones have now become very, very popular, and they have found its very high utility in the agriculture sector. These are the 5 major areas where drones can be used effectively. Is crop monitoring, where it provides a holistic view of the crop's growth. You can precisely identify any issues in the crops, damages, any kind of pesticide infestation, or a drought, or anything there. One can do a better planning and monitoring based on the observations which you have from it. And then another aspect is the soil assessment. You can extract the soil characteristics such as temperature, moisture, slope, elevation, and accurate sampling can be done. Crop protection and fertility management can be done. So basically that relates to the precision agriculture, that is right amount of application of the pesticides or fertilizer to reduce the wastage, crop health wastage, and have good crop health and production. So you can identify the crop disease or crop health in different phases of the crop growth, different stages. So you can fly these drones at different time periods and have, that's what I said, high temporal resolution at a high spatial resolution, high temporal resolution you can get, and you can monitor, and wherever you can assess that which are the areas where it may not be in the entire field that you need a fertilizer. Only a small section of the field is infested with a disease or pesticides. You can apply fertilizer only in a small area. So these what is referred to as precision agriculture can be done. Then crop damages can be assessed for crop insurance purposes. So now government is now promoting the use of drones to help farmers get the insurance, the crop insurance, for accurate reporting of events, to mitigate economic loss such as crop health deterioration. Okay, detailed digital record of the contingent plans. Then irrigation and drainage management also can be done by equipping the drones with RGB or thermal infrared camera for any kind of troubleshooting in the irrigation system. So one can manage the irrigation resources very effectively. As I said, precision agriculture, which can help understand the crop health and get a precision application of pesticides, water, fertilizers, that is where it is needed for a specific crop, and thereby increase the yield. Another example where this, as I said, in agriculture is crop health monitoring. If you see, this is an infested field in Naramari district in village Morigaon district in Assam. This is a case study done by the center in Shillong, which is Northeastern Space Application Center. And what I want to highlight here is that the size of the infestation is very, very small. Very, very small size fields could be detected with the use of drone data sets, whereas from satellite, these small fields cannot be detected where it has been infestation unless it spreads to the whole area. Only then it becomes evident. So from this early detection of the pesticide, of the pesticides can be, pests can be done, and remedial measures can be taken much in advance so that it does not spread to the whole field. So even a smallest one is done, and these are moderately effective. So immediately one can take remedial measures and spray only in the required areas. So this is what I wanted to emphasize is even the smallest size of fields or early detection of pests, any kind of disease or stress in the plants, or can be drought in somewhere there is a stress in the plant due to the shortage of water or fertilizer, nutrient stress is there, one can detect it very easily and take remedial measures before it spreads and damages the entire crop. This is also for another example where monitoring wine, this is for wine grapes, but it can be used for others. One can do a planning which area needs to be harvested first, which is ready and needs to be harvested later. So when you have these kinds of field structures, one can do a pre-planning well in advance, and accordingly actions can be taken. Or one can use drone data sets where again precision information is taken. You get a very precise slope information, terrain information. It can be used for watershed planning, for potential soil risk area assessment. So very high resolution drone data of 10 centimeters was generated, and we can create a very precise slope map in characterizing the terrain, terraces, riser height, and field slope for conservation measures. One can do this. Similarly, on drone also we talked about RGB cameras, thermal cameras, multispectral cameras. We also have Lidar sensors from on board, which can be placed on board drones, which gives you a very detailed information which can be used for infrastructure mapping applications like power lines, telephone lines, bridges, buildings. So it gives you a detailed 3D information. One can three-dimensional information one can generate for these infrastructure objects. As I said, drones have found its effective utility in disaster management, specifically in damage assessment and search and rescue operations. If we talk about earthquakes, if we talk about floods, in every place they have found strong applications. They have been effectively also used, for example, in Nepal earthquake, they were used for search and rescue operations initially, and then there were many private people who have come, who voluntarily offered drones for search and rescue operation, and subsequently the data collected was used for assessing the damage, and accordingly remedial measures can be taken for restoration of these. And in flood also has been used in India effectively in many states for again search and rescue and providing relief materials, food supplies to remotest areas for these people. In forest fire detections, they can also be used to detect using thermal cameras where the actual mouth of the fire is. Also, they can be used for extinguishing the fires with because they can reach those places effectively faster, and with the kind of spray which they have, they can be used for extinguishing those fires. So with this, I would conclude the talk today. It was just to give you an overview about what drone is, what is the basic advantage of using drone-based remote sensing, and what are the different components, what are the different types of drones. Then, but to operate these drones, there are certain rules and regulations which is being which is there in India, governed by the DGCA, Director of Civil Aviation, and it is published on the websites. One has to take prior permission to fly one has to take permission first one has to register their drones into these website. There is a dashboard where you need to register your drones first. Then wherever the area you want to fly, you need to take permission, fly, and once you fly, then you can collect the data sets. And but as I said, if it is a 250-gram drone for a hobby club, then you don't need to take any, these are free to fly, you don't need to take any permission. So drone policy is there available on the DGCA Digital Sky platform. So it's a Digital Sky platform which is there, in which you can go through with this, where you can understand the various rules, the regulations to operate the drones, how to register your drones into these platforms, into this platform, and accordingly take relevant permissions to fly drones and for your area. Because you need to take a certification also to fly the drones to become a certified pilot, training to become a certified pilot to fly these drones. But there are certain areas in each state. If you see in this Digital Sky platform, you will find also they have marked the entire country into 3 zones: red zone, yellow zone, and green zone. Green zones are few locations in each state. They have given 1 or 2 locations where it's an open area agriculture field where one can go and learn drone flying and collect the data, where no permission is required, whereas yellow and red zones are the ones. Red zones are totally not allowed. Yellow zones is where you need the permissions. So with this, I conclude the lecture. If you have any questions, you can ask. I'll be glad to answer.